Hey guys, this is me, Akrammuzzaman Onto from Elevare, and I am your IGCSE Physics instructor. And today I will be discussing one of the most common experimental concepts of IGCSE Physics, which is measuring the specific heat capacity of a solid. So without any further ado, let's begin. Now, first of all, let's define specific heat capacity and let's have a little bit of discussion on it. Okay, now what actually specific heat capacity is? Specific heat capacity defines the amount of heat energy. It defines the amount of heat energy that is needed to raise the temperature of a 1 kg substance by 1 degree Celsius or 1 Kelvin. So specific heat capacity represents a certain amount of heat energy, and which that particular amount of heat energy is needed to raise the temperature of a 1 kg of a substance by 1 degree Celsius or 1 Kelvin. That's what specific heat capacity means. And specific heat capacity is actually a property of materials. In other words, the value of specific heat capacity varies from object to object, because in order to raise the temperature of 1 kg of different substances by 1 degree Celsius requires different amounts of thermal energy. So it is a property of materials. Specific heat capacity is a property of materials. If we look at the formula for specific heat capacity, it is thermal energy divided by mass times change in temperature, and the unit for specific heat capacity is joules per kg per Kelvin. So here are a few examples, and here I have listed down a specific heat capacity of few materials. For example, aluminium, which has got a specific heat capacity of 897 joules per kg per Kelvin. Now, what does 897 joules per kg per Kelvin mean? 897 joules actually means that this is the amount of thermal energy which is needed to raise the temperature of 1 kg of aluminium by 1 degree Celsius or 1 Kelvin. Specific heat capacity of concrete is 850. 850 is the amount of thermal energy which is needed to raise the temperature of 1 kilogram of concrete by 1 degree Celsius or 1 Kelvin. The specific heat capacity of diamond is 509. Now, 509 represents the amount of thermal energy which is needed to raise the temperature of 1 kilogram of diamond by 1 degree Celsius. And so on. The rest two examples also represent the same. So as you can see, the specific heat capacity values are different for different types of materials. And so, specific heat capacity is a property of materials. Now, how are we going to determine the specific heat capacity of a solid? In questions like this, you will be provided with a solid. You will be provided with the name of the solid, and you will be asked to devise an experiment or to design an experiment in which you will have to talk or write down the steps of carrying out an experiment of determining specific heat capacity of a solid. So how are we going to do that? Now, in order to carry out this experiment, we will obviously need to have some apparatus or some laboratory equipments. If we look at the formula for specific heat capacity, it is thermal energy divided by mass times change in temperature. So if we can somehow calculate the amount of thermal energy transferred to the solid object, if we know the mass of that solid object, and if we calculate the change in temperature of that solid object, we will be able to use this formula in order to determine the specific heat capacity of the given solid. Now let's just talk about the simple things. How are we going to determine the mass of a solid object? It's really easy. Just use an electronic balance. So we'll be using an electronic balance to determine or measure the mass of a solid object. How can we measure or determine the change in temperature? It can be done by using a thermometer. We will be measuring the initial temperature before supplying the thermal energy, and then we will measure the final temperature after thermal energy has been supplied to it for a stated period of time. So the difference between the final and initial temperatures would be the change in temperature. Now, the most difficult part or the crucial point of this experiment is to determine the amount of thermal energy transferred to a solid object. How are we going to do that? Now, first of all, we can easily understand that in order to provide thermal energy, we need to use a heater, right? We'll be using a heater, but we won't know how much thermal energy can be supplied by the heater. So what we will have to do is that we need to use the heater for a certain amount of time let's say we will be using the heater to provide a thermal energy for 10 minutes. And during these 10 minutes, we will be actually calculating the power output from the heater. And then we will multiply it with 10 in order to calculate the total energy transferred by the heater. Now, the main barrier is how to determine the power output of the heater. Now, in some cases, the power output of the heater is already written on the body of the heater. But in other cases, if the power output of the heater is unknown, we will have to design a circuit in order to determine the power output of the heater. So how do we actually calculate power? We can calculate the power output of the heater by using the formula P is equals to IV, where I stands for current, V stands for voltage. So what we have to do is that we need to determine the current which is passing through the heater, and also we need to determine the voltage across the heater. So the circuit diagram might look something like this. We have got an emitter in series, and then we have got the heater which is connected to the circuit, and the heater instead is actually connected to the block, with the solid block which we are using. So we will be placing a voltmeter across it, and we will take the readings from the ammeter and voltmeter. And after taking the readings from the ammeter and voltmeter, we will calculate the power output using this formula. And after that, we'll be using the formula E is equals to P times T. Now, T is actually 10 minutes. You can also consider 5 minutes. Is actually up to you. It's actually up to you. You can go for 5 minutes. You can go for 15 minutes. Usually, we wait for a significant rise in temperature. So, you can easily understand that we need to measure time. And for that, we need to use a timer in this experiment as well. So, if we can calculate the power output of the heater and then multiply it with the time, we can calculate the thermal energy transfer to the solid object. All right, now let's just have a look at the list of equipments or the apparatus that we need in order to carry out this experiment. I have actually listed down all the equipments that we need. The first of all, we need a block of copper, iron, aluminum, and that block should have 2 holes on it. One hole should be used for placing the thermometer, and the other one should be used for placing the heater. Now, here's an interesting thing. You would be initially provided with a block, and you won't be provided the block with holes. So you need to make the holes by yourself. So once you make the holes, you measure the mass after you make the holes. Because when you make the holes, you remove some matter out of it. And so obviously the mass of the block decreases. So if you just measure the mass of the block and use it in the calculation, you are doing it wrong. What you have to do is that you make the holes first and then you measure the mass, and you will have to use that value of mass in your formula. So just make sure you ensure that thing. And second equipment that we need is a thermometer, which would be used to determine the change in temperature. The heater, which would be used to provide the thermal energy. The 12-volt power supply, which should provide the potential difference to the heater. And insulation to wrap the blocks. Insulation would be used to reduce the heat loss to the surroundings. Ammeter and voltmeter, which would be used to measure the current and voltage respectively. Stopwatch, which would be used to measure the time. Balance, obviously, to measure the mass of the solid block. And heat-proof mat, which is also used to reduce the heat loss to the surroundings. So I have also summarized the purpose of each and every equipment. You can just go through them once, and you will be able to remember their purposes. All right, now let's just look at the setup which we will be using for this experiment. As you can see that we have got the aluminum block, and there are 2 holes in the aluminum block, one for the thermometer, the other one for the heater. And the heater, as you can see, is connected to a voltmeter. Also, it is connected to the ammeter and to a power supply. So we also need a heater at the same time. We also need a timer at the same time, and we will have to measure the time, the duration for how long the heat energy has been transferred from the heater to the aluminum block. So this is actually the experimental setup. This is how we're going to use or organize the equipments for this experiment. Now, sometimes the question might ask you to design a circuit diagram, or they might actually tell you to draw this entire thing. They might actually ask you to draw this entire thing, or they will actually provide you the equipments which would be used, and will then tell you that how those equipments can be used to determine the specific capacity. So if you are told to draw this entire thing, it's really impossible, right? Like, you cannot actually draw this one. So we will have to simplify this entire diagram, and I have actually provided a simplified version of this diagram for you. As you can see that I have drawn a circuit diagram with the ammeter and voltmeter across the heater. This is the heater. The heater is actually connected to the circuit by means of connecting wires. And this is the aluminum block which I have considered for this example. I've used a thermometer. Okay, now the thermometer is actually an image. You will have to draw it by yourself, and it's not difficult to draw a thermometer. And here we have got a timer. So I've actually shown the timer as well. You can actually draw the timer like this. It isn't necessary to draw the timer, but still, in order to ensure that you're providing each and everything to secure full marks, you must draw the timer as well. So yeah, this is actually the simplified version of this one. All right, so if you're asked to draw a circuit diagram, or if you're asked how the equipments can be used to determine a specific capacity, then you will be drawing this one, because that's much simpler, right? It's very difficult to draw this one. So you can actually take a screenshot of this one and save it, and you will have to practice drawing this one, because you can't actually tell whether they ask to draw this thing or not. Now let's just move to the method. As I have mentioned before, I have also organized the entire method sequentially. And if I go through the method once, use the balance to determine the mass of the block, then measure the initial temperature of the block. First of all, we will have to determine the mass of the block, and then we measure the initial temperature of the block. Now switch on the power supply and determine the power of the heater. Alright, this can be done by using the ammeter and voltmeter to obtain values for the current and potential difference, and using the formula power is equals to current into voltage. So we will just switch on the power supply, and once you do so, you will obviously get readings from the ammeter and voltmeter. You just record those readings, and you just multiply those values together to get the power supply. To get the power output. And at the same time, when you switch on the power supply, you will have to switch on the timer as well. So it is written in the next step. Ensure the block is insulated to reduce heat loss. Heat the block for 10 minutes and find the energy transferred using the formula work done is equals to power into time. Now after 10 minutes of heating, measure the final temperature and calculate the change in temperature using the formula final temperature minus initial temperature. That's really easy. And now you have got the thermal energy transferred, you have got the change in temperature, you have got the mass of the block, you have got everything. Now just place in the formula specific heat capacity is equals to thermal energy over mass times change in temperature. Now as always, you will have to repeat the experiment several times and calculate average. This is a point which is very, very common in all your experiments in IGCSE Physics. Not only in IGCSE Physics, in IAS Physics and in IL Physics, you will find that you will have to write this point in all types of experiments. So yeah, that was the end of today's discussion. Hope you have understood the concept and have cleared all the points. I guess I have cleared all the points. If you have any queries, then don't hesitate to drop them down in the comment section below. And if you want any other concepts to be discussed in this way, just write it down in the comment section or inbox me privately.